So how do we use this duration to approximate the new price for an asset given a change of yield? Okay, as we went through earlier, once we multiply the duration, which is a measure of price sensitivity, with the change of yield, we will get percentage change of price. So in this case, I'm using modified duration, so I have to multiply with change of I. But if I'm using Macaulay duration, I will have to multiply with the change of delta. So in any ways, I will get percentage change of price. Oh, and also please remember to put the negative sign when you are doing this. It really makes sense because the change of price and change of interest must be opposite sign. If the yield is increasing, the price have to be decreasing. If the yield is decreasing, the price have to be increasing. It have to be opposite sign. Actually, I want to highlight that this is just an approximation, because in actuality, the modified duration will only accurately reflect the rate of change of price right at the point where the yield I naught is. How come? If you remember, when we are deriving our modified duration just now, we find the first order derivative. So the first derivative technically is a slope right at the point of the I naught. So the actual definition of the first derivative is limit when it is the limit when I minus I naught is approaching 0. So technically the I that we are talking about have to be practically like on top of the I naught. However, when we are using this Macaulay duration to do this first order approximation, we are allowing the I to be slightly further away from the I naught. So that is why when we are doing this, it is an approximation, because this part is not super accurate if we want to extend it to an adjacent I that is not right on top of the original I naught. So by using this modified duration as the approximation of price change, we are actually assuming the price, the new price, is approximated using this tangent line. And if you see, the tangent line is very close to the curve if the I is sufficiently near to the I naught, but if when it gets further away, the gap will be more significant. Okay, and one more thing to highlight, our approximation will always be lower than the actual price, because our tangent line is always lower than the curve. Let's see an example. Okay, a 15-year $1,000 bond with 8% annual coupon sells at par. Okay, this is the special case where it sells at par and it also redeems at par. So because of this, it's very easy to calculate the Macaulay duration, if you remember from the previous slide. Okay, so what is the price of the bond at an effective rate of 7.92% using the first order modified approximation? Okay, and how does this compare to the exact change in price? Okay, let's first try to do the modified first order modified approximation using the modified duration. So we can get Macaulay duration with this formula. So we got 9.244, and then the duration, modified duration, is simply an adjustment, so you multiply by V, and then technically if annuity due you multiply by V, you get the annuity immediate version. So it is 8.559, and then we know just now, to get the percentage change, we need to apply the duration with the change of I, change of yield. So you multiply that, you get the percentage change. So here I am multiplying first I find the percentage change of I first. It is negative 0.08%. So it is a dropping. There's a decrease of yield by 0.008%. So to get this percentage, I do this. The negative, remember to put the negative of the duration times the change of I, you get the percentage of change. Remember to put the negative sign. One way to check is the percentage change will always be in an opposite sign to our change of yield. So now our change of yield is decreasing, so our price should be increasing. It should be a opposing sign. Okay, so after we do this, this is what we got. The percentage of change is 0.6847%. It means that the price is approximated to increase by this percentage. And then so if we want to get the change of price, approximated change of price, it will be that percentage times the original price. You got 6.85. So the new price is the original price 1,000 plus 6.85. The new price is approximated to be 1006.85. If you compute the bond price, this bond price using 7.92%, using the basic bond formula, you actually will get 1006.88. So there is a 3 cents difference gap, where our approximation is lower. It makes sense, right? Because the tangent line is lower than the curve. Okay, I want to give you an alternative method to approximate the new price. Instead of using the modified duration, we are using the Macaulay duration. So this is I naught is the initial interest and I is the new interest rate. So if we use this formula, you get the new price. So what is this new formula? You take the price with the original interest rate times 1 plus I naught over 1 plus I, and then to the power of Macaulay duration. You can actually derive this equation knowing that Macaulay duration times the change of delta is approximated to be equals to the percentage of change of price. Percentage change of price. Okay, once you know this, you can derive this formula. But if you use this formula to get the new price, P 7.92 is Pi naught 1,000 times 1.08 over 1.0792 to the power of Macaulay duration. You get 1007.87, 1006.87. So if you remember, the actual price without approximation is 106.888. So the gap is just 1 cent in with using this approximation. So this method actually gives a smaller percentage of error compared to the modified approximation. Okay, I want to highlight here that if you see here, it's very easy to compute the actual price. Then why do we want to go all the way to use the first order modified duration and first order Macaulay duration approximation to approximate the price? Okay, here we are in our example, we are dealing with one single asset, but if we are dealing with a portfolio of asset, then this method of approximation will become very useful. If we are dealing with one, of course, why would we want to use all of this approximation? Just compute the actual.